Hello, everybody, and welcome to the Reuse Company webinars, where the topic today is real-time quality assessment tailoring the INCOSE guide for writing requirements. A practical solution to an implementation towards quality assessment and requirements writing assistance. My name is Cecilia Carlson, and I will be hosting today's webinar. With me, I have Elias Josfi, Sales and Consulting Engineer at the Reuse Company. This is the agenda for today. First, we will have a short presentation of the Reuse Company and the presenter. Then we will have a brief overview of the INCOSE guide for writing requirements. Next, we will see some challenges and solutions when tailoring the INCOSE guide for writing requirements, and how you can do real-time quality assessment using the Systems Engineering suite. After that, we will see a demonstration, and finally, we will have some time for questions. So, a few words about the Reuse Company. The Reuse Company was created in 1999 as a spin-off from a university in Madrid by system and software engineers. Our headquarters is in Madrid, but we also have an office in Stockholm, Sweden, and a delegation in Tokyo in Japan. In 2021, we are planning to open an office in the US. Our mission is to promote a reusable, scalable, and global solution to a smart and interoperable systems engineering environment. And we do this by offering a semantic knowledge-centric approach. The Reuse Company is also called TRC. We like to say that it's easy to remember if you think of T like in traceability, R like in reuse, and C or almost Q like in quality. You can also apply these concepts to other topics. Now, let me introduce you to the presenter. Elias is a sales and consulting engineer, and he got his master's degree from the University of Montreal in Canada and the IMT Atlantic School of Engineering in France. He has experience in sales and a technical background in energy and mechanical engineering. He has also been involved in a research project around the environmental impacts of end-of-life management of aircrafts. Elias is passionate about international projects and languages, and currently he speaks 4 languages fluently. So let's start then with the presentation. Hello, Elias, please go ahead.
Hello, Cecilia. Thank you. Thank you for the introduction. And hello, everyone. Thanks for joining. So first of all, before we get into the topic of today's webinar, we will introduce some concepts around the INCOSE and the INCOSE guide for writing requirements. So the INCOSE is the acronym for the International Council on Systems Engineering, which is a non-profit organization founded in the 90s with the aim to provide principles and practices around systems engineering. Systems engineering being an interdisciplinary approach meant to reach successful systems by defining processes that any system development should follow to avoid failure. So this is an organization that is present in the whole world, and today has around 3,500 certified systems engineers. And from these 55 working groups, one of them has been working on the requirements engineering and how to provide a guidance to express textual requirements. So that's why they came with this. They came up with this guide for writing requirements, which goal was to expand and promote the body of knowledge of requirements engineering, and also present its benefits within the systems engineering community. So this guide provides a comprehensive set of characteristics, rules, and attributes to write well-formed requirements statements. So first of all, this guide as we explained, provides characteristics, attributes, and rules. So the statements will be based on some characteristics and also be complemented by some attributes. And all this makes a specification, so need or requirement expressions, which can then be processed into the further processes of the system development. But everything that is built here will be based on the rules that are defined in the INCOSE Guide for Writing Requirements, which define, for example, the syntax or the elements that should be mandatory or, on the contrary, should be avoided in a requirement. So if we describe the elements that form the guide, first of all, we have 14 characteristics of either individual or sets of needs and requirements. So these characteristics provide rationale and guidance to help understand the requirements. These characteristics then are included, as you see here, in 41 rules, which help formulate how the requirement should be written, and an explanation with examples, exceptions, as we will see later, that you should respect in order to have high quality requirements. And we can, of course, add some attributes to explain the requirements, to give context, and help also respecting these different rules, comply with these different rules. So if you want more information on how we implemented the INCOSE Guide for Writing Requirements, how the technology of the Systems Engineering Suite helps in developing a real-time quality assessment following these rules, I invite you to follow this link after we send you the presentation to watch this webinar we presented last year. But today we will focus on how this real-time quality assessment can help us face the challenges of the tailoring of the INCOSE Guide for Writing Requirements, and of course why we should tailor these guidelines from the INCOSE Requirements Working Group. So first of all, this INCOSE Guide for Writing Requirements is a well-known universal fundamental framework for the quality of the requirements. Of course, it represents a state-of-the-art background, so that anyone could rely on the same specific rules for a project, and it's a very good starting point. So these are some of the benefits of this guide. But what is very challenging is that applying these rules could be very tedious and time consuming. So we should think of the rules that could really help in the requirements engineering in a specific context, or decide which rules could be discarded from the project because they don't fit the project, or it's not necessary using them in such in a particular context. So the idea is to avoid considering these rules as written in stone and to follow them thoroughly one by one, but rather choose the rules that are of importance in the project, and avoid using them as a single checklist that we should all follow. So this is the first element that we have when we think of this book. And as I said, we have three elements here, three key elements that describe the way the requirements should be formed in the specification. But in order to introduce the tailoring, we should introduce other elements. So that's why we implemented a set of quality metrics that map the rules of the INCOSE Guide for Writing Requirements. So this mapping table here is available on our website if you want to look into detail the different rules and how they were implemented. So This gives room for tailoring because one rule can be implemented by several metrics, and the metrics, they provide indication on how we should measure the element that is the property that is intended by the rule. So for example, if we want to measure the fact that a requirement should only describe one action, then we will count the number of action verbs. So the metric will count the number of action verbs, and then the quality function is the conversion from this value that we obtain from the metric into a quality level. So for example, we have binary quality functions. So 0 and 1 could be high quality, and more than 1 could be low quality. So this is binary. Concave, convex, we have different profiles that we can apply. And of course, for the same metric, measuring the same thing, we could have different functions. And that's how we can change a little bit the way we assess the quality. Let's see, for example, here, if we apply a rule, let's say that this rule is implemented by 2 metrics. Then these metrics each have a proper quality function. And from this quality function, we then reach a quality level. So depending on the value that we gathered from the metric, we have a high, medium, or low quality. So this is what we intend to do by introducing these 2 characteristics. So for example, here we have rule number 6 that states that we should use consistent units. In our implementation, we have 3 different metrics to tackle this rule. The first one is to ensure that the numbers are followed by units or anything that could describe a noun or a system element, a component, and a user, so anything that prevents the writer of the requirements to write something like the speed shall be 5 without any description, any measurement unit after. Second one is to detect inadequate use of measurement units. For example, speed cannot be related to kilometers or inches or feet. So we should use consistent units, and we can detect the relationships that are not compliant with regards to the knowledge base. And the last one is to avoid mixing up different measurement units. So if I use BTU and kilowatts in the same specification, I will have a message telling me that this is not consistent. So you see that we have 3 different metrics. Each one will have its own quality function, and I can decide to apply either one of the metrics or all of them, or 2 if I want. So this is how we start tailoring the INCOSE rules. And one interesting point here is that in some of the rules, we have, even in the definition of the rule from the INCOSE Guide for Writing Requirements, we have room for tailoring. So for example, rule 2, use active voice. The first sentence is use the active voice in the main sentence. So what is the main sentence? We should define what the main sentence is. And it suggests that, for example, a condition sentence, which in most of the cases comes before the main sentence, which describes the action or the functionality of the system, this condition sentence could have a passive voice. For example, when the system is started, is describing a state that triggers an action. So this is not harmful for the requirement. But saying something like the system shall be started, we need to know who or what is starting the system. So in the main sentence, the passive voice could be harmful. So in this example, we see that we have room for tailoring, and we will see later how we can distinguish the part of the sentence where the passive voice is used. Same for the combinators. If we have here logical conditions, for example, state 1 is off and state 2 is on, this is something that we can accept. But on the contrary, if we have 2 actions, and or, invite us to gather several actions in the same requirement, and this is wrong. So in this case, we don't accept combinators. So in the same way, we can make the difference between good and the bad use of combinators or passive voice. So this is an understanding of the tailoring that is needed for the rules defined in the guide. And as I said earlier, this tailoring and this implementation of the INCOSE guide for writing requirements is quite challenging because we should adapt to many different dimensions. The level of abstraction of the document, the level of criticality of the system, and also the life cycle stage in which we are finding ourselves, and also the skills of the team members, the different dimensions of quality, correctness, completeness, consistency that we should use. And the idea is to at the same time to define a common framework for all the teams. So we should tailor, but we should also define a common background. So this is quite challenging, and we will see how an automated solution can help in this process. So from the challenges that we have to face, first of all, we should not consider the guide, as I said, as a frozen set of rules, something written in the stone, but we should consider the different dimensions that help us understanding why we should tailor. First of all, what we called the three-dimensional tailoring space, the stage in the life cycle, the level of criticality of the system of interest, and the level of abstraction. Then we should also look beyond correctness and also tackle consistency and completeness. And we'll see how this is important as well to consider. We should adapt to the skills of the team members and use also the patterns or boilerplates to help defining structures and exception for different rules, and to help in the adaptability to different types of requirements, because depending on the rules that you use, some of them could be applied to some of the requirements, and some of them could not. So we will see examples of that as well. So let's consider a three-dimensional tailoring space as this one. We have systems that are not equally critical. The entertainment system has a low level of criticality, of course, and we can go up to a fire detection system, which has a high level of criticality. And if we consider the documentation of this fire detection system, a marketing requirements document, a functional requirements document, and a user interface requirements document, here we should consider different rules to tackle this approach. So if we have different sets of rules here, we will see later this concept of belts and how important it is. Because of the criticality of the fire detection system, I won't start with a white belt, which is the first level, as if you think of the martial arts belts. We should probably start with a blue belt for such a system, whereas, for example, for the entertainment system at the early stages, we could start with a white belt. So first set of rules, you see, for the same rules, we have three metrics here. Maybe the white belt could have only one, if we think of the example with the units. And then if we move to a second belt, then we could have other rules tackled, because I'm in a more advanced document, and I'm tackling the preliminary design here. And then if I go to the black belt, I could have even more rules and go beyond in the level of detail and the life cycle stage as well. So this is very important to follow this progressive approach, to avoid having too much rules applied to something that is not really requesting that much thoroughness in the process. So we'll see later also another benefit of this progressive approach. And as the INCOSE guide for writing requirements states in the section 1.5 called concepts, it's clearly mentioned that the requirements are expressed differently depending on the level of abstraction, and therefore we should apply the rules differently as well. So that's also another opening for the tailoring that we are suggesting. For example, for stakeholder requirement, the ambiguity could be accepted, whereas for system requirements, we don't accept ambiguity. We should have something clear and very simple to understand without any misunderstanding that could occur. And then for the accuracy, we could be less accurate in stakeholder requirements, whereas in system requirements, we should provide specific tolerances and be as accurate as possible. Same for the level of criticality. This is quite obvious. A non-critical system shouldn't have the same set of rules that a critical one. And the lifecycle stage is also important if we consider here the requirements engineering process as adapted by Carl Wiegers here. Of course, if we start using rules at the requirements authoring phase, the rules that will be used here would not be the same as the one used for inspection at the verification phase. For example, we could accept words like TBD because as I said earlier, we don't need accurate measures at this point. But then we could not accept something like TBD in the verification phase. So the idea is to progressively increase the level of quality and fix errors here by reducing the number of iterations. So the earlier we start applying rules, the less iterations here we have when we start fixing the errors. So and why is it important to start from the beginning? It's because, as you see here, most of the defects, so 7 out of 10 defects, are introduced in the requirements phase. So this means that we should, from the first phases of the requirements engineering, and of course of the system development, we should detect these defects to avoid them to transit to other phases. So that's why we should use a tailored set of rules for authoring, but then at the same time we should reduce the number of defects discovered, because we should increase the number of defects discovered at the beginning by inspecting properly these authored documents that we have. And the idea is to close the gap here between this curve and this one. So one solution to tackle this approach of progressive quality assessment and tailoring is to think of the quality assessment as a three-dimensional aspect. We have correctness, which is considering individual requirements. So, for example, correctness will mainly cover aspects for the syntax of the requirements. So, for example, avoid wrong measurement units, or use the passive voice, or use negative expressions, vague terms, and so on. So this is the correctness aspect. And then we have consistency and completeness, which will go beyond this approach, because consistency is checked among the sets of requirements, which means that I will check one requirement and compare the information in these requirements with the other. For example, detect duplicate requirements, detect wrong use of properties for a system, or mixing different measurement unit systems. So these are consistency metrics. And we have completeness, which is checking how many concepts of my document are being mentioned with regard to what I should define in the specification for the system. For example, if I expect 40 system elements in my specification and I only have 30, then I will have an incompleteness score of 25%, which means that I should write other requirements to complete the specification. So this is the completeness aspect here. And these three dimensions are needed to have a high quality document in the end of the process. So of course we should tailor the INCOSE guide following this approach. And another reason why we should go beyond correctness is that even if the clear statement of requirements here is the third main reason for success here, as described by the chaos report, it's also important to consider the project failure factors, and one of them, one of the most important, is the fact that requirements are not complete. So requirements and requirement specification, of course. So that's why we should focus on completeness. And if we consider the different characteristics in the INCOSE guide for writing requirements, if you have a look at characteristic C4 here, although we have 12 rules tackling the completeness of individual requirements, and that's very important to distinguish from the sets of requirements here. Here in C10, we only have 3 rules tackling the completeness of specifications. So that's why we should provide here other elements to consider this characteristic, which is very important, as we mentioned just before. So let's see how the real-time quality checking in the systems engineering suite is done to tackle completeness. So it's if we consider this product breakdown structure of the computer with the different system elements and components, and here are some states and state transitions for this same system, and a small specification here. What completeness will do is check that all the concepts are covered in the specification. So I will parse the document and check if all the elements are mentioned. So the elements could be systems, could be states, transitions between states as well, and also properties. And the completeness will at the end tell you what is missing in the document. So this means that here my score of incompleteness is quite high, so it means that my document is not finished. I should tell the people writing the requirements that we should have at least one requirement for each of the elements here. So that's for the completeness. In the same way, we should consider consistency as an important factor. So consistency here, if we use this similar structure here and the same state machine and go over the specification, consistency here will tell you that this requirement is correct because the relationship here is exists, but this one is not in the specification. That's why this one is not correct. So you see the completeness here is fine because I'm talking about the computer. So I have a requirement talking about the computer. So that's contributing to the completeness, but this requirement is wrong. So that's why these dimensions should work together. Same for this requirement here. This transition doesn't exist. So although I'm contributing to the completeness by mentioning hibernated mode and off mode, I'm still having a problem with this transition. So I should have a quality dimension, which is consistency, to detect it. And the same way for properties, these 3.5 kilograms is above the limit here. So we should consider this also as a consistency error. Then we can also look at the skills of the team members. So depending on the level of maturity that the team has in systems engineering and requirements engineering, we should apply the rules differently. So of course, if we start with a white belt with few metrics for example, for beginners in requirements engineering, then in this case, we could have a high quality of requirements in the first quality inspection to focus on the most frequent errors. And then we can improve the quality assessment by including other metrics, as I showed in the first slide with the tailoring space. And then the more we go on the right here, the more mistakes we will detect. And after we reach this point, we could go back to the specification here and modify the requirements that need to be improved, and then go back here or restart from yellow belt maybe and go further on the right and continue with the process. So of course, if the team is skilled in requirements engineering and knows most of the rules of the INCOSE, of course, maybe they will start with something closer to the final configuration. But that's why we should consider, depending on the teams, which belt here is the right one to begin with. So if we consider the different concepts that we use from the natural language processing and the advanced semantics that we provide for the quality analysis of the tools, the white belt will start with basic syntax and the control of the vocabulary and the use of system conceptual models to check the relationships between systems, as I showed you earlier. But this could be a first configuration. Then we could rely on patterns. I'm coming to it just after. Use some semantic analysis metrics. And then as we go up, we could improve the quality assessment by including the completeness and consistency aspects, some relationships and formalization, which is a smart understanding of the relationships in the requirements, and then also include ontology, retrieval, and reuse capabilities. So the patterns, they're quite challenging because only two rules are relying on patterns in the INCOSE guide for writing requirements. So although the patterns are very important because they provide a lot of benefits, they're not covered by a lot of rules in the INCOSE guide for writing requirements. So what the patterns offer is, first of all, a concise, easy to read way of writing the requirements. Secondly, to easily classify requirements into different categories. For example, functional, non-functional requirements, structural, physical, state transition requirements, and identify the missing requirements. If we talk about the completeness, my completeness could be to check that I have at least one requirement of each of the categories here. We can find duplicated requirements because if we follow the same structure, it's easy to identify what requirements are similar, and also it's a good way to follow up with other activities such as analysis and implementation. So it also improves the traceability between the different processes. So the patterns are mentioned in the Appendix B of the Guide for Writing Requirements, but the guide does not introduce a list of patterns of standard boilerplates that we should start with. So we invite you to refer to some well-known catalogs, such as those here listed. And I can tell you that we already have these two patterns pattern catalog as a knowledge library developed in with the tools. So we can you can download these knowledge libraries from the website and use these patterns as a starter for building up your requirements documents. So let's see here, for example, another challenge that patterns can help us face, which is the adaptability to different types of requirements. Here, the rule 16, avoid not, can be applied to all the requirements, but we should pay attention to specificities here in the document. For example, functional requirements don't need to have this negative expression here, but in the safety requirements, for example, the shall not open the doors is the expected behavior that we want to address here. So this, in this case, in the case of safety requirements in general, this negative expression is not a problem. So we should make the difference here, and that's why with patterns and advanced semantics, we can detect some exceptions like this, or use filters based on the type of requirements. So the attribute, as I mentioned at the beginning. Another example of the use of patterns to detect the different cases and exceptions is the passive voice. As I mentioned in the beginning, we want to enable the passive voice detection only in the main sentence. So in this case, is activated is a passive voice in the condition, and be redirected is a passive voice in the main sentence. So the tool only detects one of them because we clearly enabled the metric that only detects it in the main sentence. So the thing is, this pattern is detected as the condition. So that's why in this case, the metric is not complaining. In the same way, the patterns help us improve the consistency between model-based systems engineering tools and text requirements, so that we can use the same vocabulary coming from the different sources, Capella, Rhapsody, Magic Draw, simulation tools like Simulink, and with the use of an interoperable knowledge interface, we could gather information from different sources and make the text requirements consistent with all of them. So that's why the patterns are very important here to prevent the users to describe the same models as different elements. And what I mentioned as well to improve the level of consistency is to use specific knowledge libraries for example, space industry or automotive industry, if we consider the ISO 26262. And we can also use the INCOSE GfWR writing requirements library featuring the rules that I will show you later in the demo, and also pattern-based libraries like EARS and the master patterns by Sophist. So these libraries can be downloaded on our website in the libraries section. And in the end of the process, to tackle all these, to address all these challenges and provide a solution that is not time-consuming and that helps you adapt easily from one situation to another, is to use the Systems Engineering Suite. So as you see here, all the elements here, all the different workstations of the tool revolve around a common background, which is a knowledge base. So this is where we define the rules and the different vocabulary that will check the different documents. And that's why here, depending on the level of change that you have from one document to another, depending on the level of criticality change that you may have, you should decide the concepts that you want to apply to specific documents. So we will see how here the quality studio, so the quality assessment tool, and how the authoring tool can work together to implement this tailored progressive quality assessment approach that we are fostering. So important to mention also that these tools, of course, connect to the most used requirements management systems and even Excel and Word documents, so that you can analyze elements from different sources in the same workspace, let's say. And in the same way, the authoring tool can be integrated as add-on into different tools. The same here, requirements management systems, but also modeling tools. And the knowledge interfaces could be set using the knowledge manager to connect to models like Rhapsody, Capella, for example, Magic Draw, and so on. So having said this, if we go to some of the concepts here, the quality assessment tool provides you with this implementation of different characteristics, as I mentioned in the beginning, to convert the metrics into values that build up the quality level of your specification. As you see here, we have some elements here to see real-time the quality assessment. We have some specific views for the completeness and for the consistency to make sure that we use consistently the different measurement units and the different properties for a system. In the same way, the authoring tool provides you with patterns guidance and automatic suggestions of terms based on these patterns. And of course, the real-time quality check that is also available in the RAT authoring tool. So we'll see also examples of this tool in the demo. And to conclude, before going to the demo, for each challenges, we provide solutions that all result in using an automated tool, which is the the systems engineering suite, which is combining automatic tailored assessment of the documents based on the INCOSE guide for writing requirements, and the possibility to apply progressive quality configurations, to rely on patterns to improve the level of quality, and to use natural language processing capabilities and advanced semantics. So, of course, in the end, if we conclude, the idea is to transit from a manual assessment, manual inspection, which could be very tedious for the subject matter expert, because we have to build up all the concepts of the ontology, so the so-called knowledge base, but also going from one rule to another for each of the requirements. Whereas in the meantime, with an automated assessment, we save a lot of time in this process. We can manage several ontologies at the same time and reduce the time to assess the different rules. So let's start now with a demo of these different capabilities. So first of all, we can start with the authoring part. So as you see here, we have a doors interface open. So we start editing a module in the doors project. So the first here module that I'm modifying is a functional requirements module. You see that on the top you have a authoring tab that is added. This is the add-on of the RAT authoring tool that is implemented inside doors. So you can insert new objects from there. You can also do it, we'll see later, using the right click inside the table. And of course, when we generate the quality view, you see that we have access based on the RQA quality assessment, the RQA quality studio, we have access to the quality level here. So of course, when we keep going, we can create an object using this menu or using the menu here in the interface. So the first element we will create is, for example, a requirement such as this one, shall manage the accumulator. So this requirement, of course, is using a vague verb manage, but this is the first configuration. So so far I'm doing quite good with these requirements. I can also use the menu here to create another one. And if I start writing when signal 1, and then I stop writing and I save the requirements, I will have here 3 main mistakes. The first one is the missing qualifier. So remember the rule number 6 I showed you in the beginning of the presentation. So here I miss one qualifier after this one, or and I also miss the modal verb, and my requirement is too short, so I must include more information. So if I keep going, you will see that the quality assessment can be done inside the interface. I don't need to enter the editor to get the new quality. So if I keep writing, when signal 1 equals 10, the information shall be displayed by system A, system B, system C, etc. So here I get the high quality assessment right inside the interface. Let's do the same in the other module I have here available, which is a non-functional requirements module. And if I generate the quality view as I did in the first module, I get the quality results. And let's keep feeding this module with new requirements. So let's see here in the menu, the example I have mentioned about the TBD word. So TBD here will be accepted in this first assessment. So you see real time on the left, on the right, the quality assessment. And as it's finished, I can save the requirement, and I get, of course, the high quality here written with the date of the assessment. I can do another requirement. So let's imagine I write this requirement here. Of course, here I'm writing in the title section, so I will get the mistake, of course. So I need to change the object text and not the heading. So that's why here I get the same mistakes as before. One modal verb is necessary. The requirements must have at least one paragraph, and more information shall be included. So then if I change the properties here and I move these from the heading to the object test, then I get high quality at the end of the process. So I can save this requirement, and let's create another one now. This one will be written using the pattern guidance. So let's select a pattern guidance here. For example, a structural requirement. So you see here the use of patterns is very interesting to rank, to classify the different requirements into the different sections we want to address in the document. So if we select the structural requirements here, we'll see that we can write something like the train will have 25 antennas. So I follow the patterns, and you see that then I keep writing, and I get high quality, and the green frame here means that the pattern is matched. So then after I did this, I can save my module. And now let's go to the requirements assessment tool. So when we open the tool, the first thing we see is the connection window. So you see that we can connect to different repositories, the doors I'm just working with, the Excel sheet, and also a doors.ng repository. So we have different combinations. We can also combine different documents to analyze the whole set of requirements. But now let's open the doors module here. So the first thing we have to do is to select the module we want to open. So we can of course open both, but let's start with the functional requirements module. So this module, as you see, has the quality assessment set, and we can see the last requirements that we created if we rank by quality date. So the two requirements we just created indoors. And from this point, we can create a snapshot to save the instant quality assessment. So we will see the benefit from this is to follow the trend of the quality assessment. So we can do this for this module. We can change the module here with the module selector to go to the other one. And we open the other one, which has more requirements. So it's taking a little more time, of course, to load. And in the same way, we can rank here by quality date and see the 3 requirements that we just created with the ID and all the information. And we can create also a snapshot. And if you go to the scoreboard, we will see that we just saved a snapshot that will later give us the trend of the quality. So if we change here to the other one, we see that we have here only 10 requirements, which means that I've changed the module here. So I can see right on the spot the different snapshots for the different modules. So here, if we want to follow the progressive approach that I mentioned in the presentation, if I select this baseline, which is baseline 1, by the way, this is the first baseline of the INCOSE guide for writing requirements library that we offer. The second baseline is here. The difference is that this one is providing domain and non-domain dependent metrics, whereas this one is only using non-domain dependent metrics. So let's compare this baseline with the one I used, the 0, and let's see the differences. So here I can see only the added and modified or removed metrics. I have 22 more metrics in this baseline 1, so I'm expecting a more thorough quality assessment using this one. But in my case, I will use then after the baseline 3. So let's see in detail how we implemented the INCOSE guide for writing requirements. So if we open this baseline 1 I was just mentioning, we see that we have the different rule numbering of the INCOSE guide for writing requirements with the characteristic and the metric numbering that we provided to easily identify the different metrics. So we have below the quality functions, as you see, some of them are convex or concave, some of them are binary, depending on the different cases. So if we see here that we have 47 metrics, 37 of them are enabled, And the reason is for this is that, for example, you can also arrange the view. If we look for the passive voice, and if we remove the filter for the enabled requirements here, we see that we have 3 different metrics for the passive voice. One is checking anywhere in the sentence, the other one is checking after the modal verb, and the last one that we enabled is checking only outside conditions. So depending on your project, you can decide to use one of them. So this is a practical example of the tailoring. And in the same way, we can compare the baseline 3 that we want to use with the baseline 0 that we applied at the beginning. We have 31 more metrics. So this one is even more strict, is even stricter than the one I was comparing with before. So if we apply this baseline, first of all, I need to assess the quality of this module. So we had high quality for everything in the first assessment, but now you will see that some of the requirements will get a low quality because I'm introducing with the new metrics, I'm introducing some new capabilities for the assessment that detects new mistakes. So I'm saving a snapshot for this to keep following the trend. And if I go to the evolution scoreboard, first of all, you can see the actual state, and the evolution scoreboard shows you the evolution here. You see the quality has decreased. We can do the same for the other module. And we can then calculate in the same way the quality assessment. You can do the quality assessment, get the results. So here, as you see, it's saying saving module, which means that I'm saving the quality assessment here inside doors. So we get the results indoors afterwards. So we'll see it. And then after I save it, I can see also the trend here in the same way. So I can see change from one module to the other as I did before. And then if I go back to the doors module, I can see that I get the results from the quality that I just calculated in the quality studio, and I can start changing the requirements. So this one is saying passive voice out of condition. If you look at the one just above, this one has a passive voice in the condition as soon as the system is started, and you see that it's high quality, so it's not complaining. So it means that the pattern that detects conditions is skipping the metric. Whereas here, the passive voice is in the main sentence, which means that I have low quality in this case. So let's change the sentence here and write, for example, the user shall install the system, then I get a high quality. And then I can keep modifying this module, or I can also go to the other module and start modifying. Here I have a metric that is very advanced in this case, because it's telling me that I'm using an invalid relationship between system and system element. So for example, the air conditioning system doesn't have any auxiliary system. So I can do the change here in the interface, writing a correct system element, and then get a high quality as well. And I can also do the same for this one. I can open an editor. I get the information here that the BBS relationship is not correct, and I can then change this requirement with something that is consistent. So you see the pattern now is you see checking, it's correct, pattern is correct, and metric on no metric, none of the metrics is complaining. So we get high quality. We can do the same for the other requirements that are in low quality. For example, this one, if we change HVAC by air conditioning system, we get, of course, high quality. But here, I said in the presentation that it's important to go beyond correctness. So here, this requirement is correctly written. The syntax is good. But what about this 300 kilowatts here? Is it correct? So let's see. If we open the editor, we can have access to advanced metrics based on consistency and completeness, as we presented in before the demo. So here, if we select the physical requirements, here we will see that my requirement is following the pattern. So this is good. But then let's, for example, check the consistency. Here I have a property consistency metric, and I can get the information that this is not consistent. I have 300 kilowatts, but I'm only expecting as a maximum 18 kilowatts. So let's change here by 25 HP. You will see that the tool is even converting the assessment here. So sorry, I was here. Yeah. So you see that it's converting the 25 horsepower to 18.64 kilowatts. And then if I, of course, change the value, I get a high quality. But then I can also so see here it's a green tick for the high quality. But then I can also check the consistency of the measurement units. So you see here that it's complaining, the red tick here, because I have powers in British Imperial systems and powers in international system. So I need to choose between these two systems, which one I want to keep. So then if we go to a last example, this TBD here is not accepted anymore, as I mentioned in the presentation. Let's, for example, select this and write it with a tolerance. So if I write this, the tool will tell me, okay, tolerance is higher than expected. Then if I change to 10, tolerance is maybe too small. So these values of tolerances that I accept or don't accept depend on the quality functions that I set in the quality configuration. And if I write something like 25, which is quite in between, then I get a high quality. And of course, I can do the same with the last pattern, change here with the editor, follow the trend here. If I write the radio and the antenna is a correct relationship, and will is not an accepted modal verb. If I write shall, then I get high quality. And if I finish the work, I can go to the quality assessment and see the trend. So I see that I slightly increased the number of quality with the few requirements that I edited, and in the same way for the other one. And then I can also see the reports here, get the information of the metrics, and for each of the requirements here, see the different mistakes, the conflicting measurement unit systems, the properties here with the conversion, horsepower to kilowatts, as I mentioned, and so on. So this is it for the demo. I also want to tell you that we have a book that we wrote about the real-time quality assessment of the INCOSE guide for writing requirements and a tailoring guide. So if you want to request a copy of this book, you can follow this link to the form to ask it for it. So thank you for your attention, Cecilia. I hand over to you now for the questions section.
Okay, thank you very much, Elias. Elias will answer your questions in a minute. So if you want to ask him anything, please write down your questions in the chat box. You can address them to the reuse company or open to everyone. Meanwhile, I will tell you about our next webinar. The topic is Smart Traceability, the core of a successful systems engineering discipline. Traceability is a must when aiming to cope with international standards, guidelines, and best practices. This is a tedious and time-consuming task, especially when traces involve items coming from different disciplines and tools. We need an easy access to the different configuration items, the definition of traces among them, generation of traceability matrices, impact analysis, and semantic analysis features to suggest missing traces and manage suspect links after changes in a smart way. In this webinar, we will present a new version of the tool Traceability Studio. This tool provides an easy-to-use answer to all the challenges mentioned above. making this demanding activity easy and affordable for companies of all sizes. The dates for this webinar are the 17th and 18th of March. Questions? Let's see. You have shown the completeness check. For us, a specification of an architectural element does explicitly not address a subordinate system architecture. The reason for us is not to specify a particular system architecture too early. The subordinate architecture elements are described in a separate specification and are linked to the requirements of the upper level. My question, is it possible to apply the rules across multiple specifications?
Yeah, so thank you for the question. Of course, you can decide to apply a common set of rules for different specifications. So if you want to open two modules, two doors modules at the same time, you can, of course, do it by selecting the modules in the RQA. When, as I showed you in the demo, when you open the tool, it asks you which module you want to open. So you can open one module, or you can open 10 modules at the same time and do the quality assessment for the whole project. As a consequence, it's the whole project that you will be analyzing. So yes, of course, you can do an assessment that goes beyond the module by module approach.
Okay. Some rules can only work if the project-specific ones are made available. For example, the project structure or architecture or certain terminology, possibly also state diagrams. Question, which project-specific adjustments are necessary and useful?
Yeah, thank you. This is a good question. So, of course, the knowledge that we will be applying to check the quality of the requirements will depend on, of course, the project that you're working on, but also the rules that you are applying. So if you only want to apply rules that are addressing the syntax and the terms to avoid, of course, you don't need to do any adjustment. The slight adjustment that you would have to make is that if you have to change the vague term that you want to apply in the list of vague terms, for example, you could change the list using our knowledge manager. But of course, if you want to import vocabulary from the specific project, you have specific relationships, connection to model-based system engineering tools, you could do it. So I could show you a quick example here. For example, if we connect to a knowledge base using our knowledge manager tool. So let me just share now my screen with the knowledge manager. So if you open the knowledge manager, you see that the first thing it's asked is if I want to open interfaces. So these interfaces here are coming from different sources. So I have a signal values from an Excel sheet. I have a Protege external ontology and a Rhapsody model. So for example, I can get PBS elements coming from the native ontology. So these will be always in the database, but I can also import these elements. You see the small USB key here. This means that it comes from the Rhapsody model. Of course, if I hover on the USB key, I can see that it comes from the Rhapsody model. And also some other elements could come from the Protege ontology. So depending on the different sources that you have, you can also enhance the level of quality by introducing the new concepts coming from external sources. Same for the transitions. I can have the different transitions from a state machine coming from Rhapsody, as you see here. And you can use then this information to check the quality of your requirements. So, and regarding the vocabulary, we have Excel import capabilities. You can check your Excel sheet and import the terms, the term tags, which is the syntactic category. So of the terms, you can import values and qualifiers and so on. So you see that if you have a structured vocabulary in Excel sheets or even in text files, you can use these elements to change the knowledge base and use the proper set of rules to analyze your document.
Okay, thank you. Another question: how does the tool cope with unknown vocabulary?
So in the same way, you can import vocabulary. You can also, during the project, identify some new elements that are not part of the knowledge base. So, for example, if I open my doors module, and I decide to use a term that is not yeah, I need to connect my VPN to have access to doors. So if I open a doors module and then let's take the example of the HVAC system that I didn't have in my knowledge base. So I could use this this HVAC system information and say, okay, please add this element to the knowledge base so that our users in the future could use this useful information. So for example, let's go back to the functional requirements. And let's see, here I had this requirement, air conditioning system. Let's put back HVAC system here. So of course, if I load the quality view and I open here the editor, I'm getting the information from the knowledge base and all the information. Let me check if I have the right database. Yeah, it's the right database. So it's not the right database. I should select this one. This is the database I want to use, the active one for the assessment. And I will then show you how we can suggest a term to be added in the knowledge base. So now it's loading the knowledge base. So let's now reload my ontology to get the right database for the addition of the requirements. So I'm loading the semantic engine and all the metrics that I need for the assessment of this requirement. So of course here I don't follow the pattern because I didn't select the property requirements. It's not this one, it's the physical one here. So now I'm not following the pattern because HVAC system is not known. So I can decide to select this term and say, okay, add this term to the ontology. So add term in the ontology, this system is part of the project. And then I have created a suggestion so that when the user that manages the knowledge opens the tool, then he gets a suggestion. So HVAC system, add term to the ontology. I get exactly the information that I just introduced. I can, okay, I will add the term HVAC system. I can change here. I can force the capital letters here. So I have it here now in the knowledge base. So I can decide to force here the original format of the term. This term will be a noun, and it will also be a system element as well. So once I get this information, next time I will use this HVAC system, if I close here, now if I reload ontology to get the last information, if I edit this requirement, I'm expecting my requirement to be correctly detected because I have. So you see the quality is high now, and if I select my requirement with the information that I specified, then I get a high quality requirement and a pattern that is matched, meaning that my term here is known. And of course, if I want to check information on the term, I can get the information that I just introduced. So based on this, I can also tell the knowledge manager, okay, you put this as your original format, but you can suggest to modify this. And then we can communicate between the different persons. We have some lessons learned and quality forums here. If we want to add some elements, you can create threads and communicate. So this is it. I don't know if you have any more questions, Cecilia.
No, this was the last one. So thank you, Elias, and thank you very much, everybody, for attending. If you have more questions or want more information about our tools, don't hesitate to contact us by email directly to Elias or to contact@reuscompany.com. You can also find information on our website, reuscompany.com. Thank you very much and goodbye.
Thank you. Bye, everyone.